In this lesson, we'll be covering the formulae in radian measure. Okay, so there we are on page 60 of your Discovering Mathematics textbook. So there are two formula that you actually need to know. These two formula are actually given, okay, in the formula sheet itself, but you need to know how to apply them. So if the angle they give you is in radians, which we learned in the previous chapter, so we can use these two formula. So for example, if I want to find the arc length down here in the diagram, the arc length is simply given by the product of the radius times theta. Similarly, if the angle is in radians and I want to find the area of the sector here, the area of this sector is simply given by half times r squared times theta. We'll just dive right into some examples to actually see how we can apply these two formulae. Okay, so first and foremost, trig 14 can be found on page 61 of your textbook itself. So first we want to find the length of the arc AB. So the arc AB, if you remember the formula from the previous slide, is actually r times theta. So let me just show you, is r times theta. So what we have here, the radius is 5, and since the angle is in radian, we can apply this formula times theta. So what I get is equals to 12 centimeters. Next thing, the area of the sector is simply equals to, if you remember from previous slide, half r squared theta. So what we have is half times 5 squared times 2.4 radians. So the area of the sector in this case is 30 centimeters squared. Okay, we now move on to trig 15 from your textbook. So trig 15 shows the plate. Okay, they give the area and they give the radius as well. So first and foremost, we want to find the angle POQ in radians. So now if it's radians and we have the area, we should use A equals to half r squared theta. So the formula that we will use for the first part is area is equals to half r squared theta. So I'll just write down half times 12 square times theta. Okay, theta is unknown. All right, the theta is over here, is equals to 125 cm square. So if I solve for theta in radians, is 2 times 125 divided by 12 square. So my theta in this case is equals to 1.736, is equals to 1.74 radians. Remember, when we look for the angle in radians, it's given correct to 3 significant figures, unlike angles in degrees that's given correct to 1 decimal place. Now we need to find the perimeter of the sector OPQ. So let me write it down. Perimeter. How many portions actually made up the perimeter? There is the arc, there's one radii, and there is another radii there. So therefore, what I'll say is the perimeter equals to the arc PQ plus OP plus OQ. So the arc PQ is equals to r times theta. If you remember from the very first part of the thing, the arc, when the angle is in radians, you can use r theta. So in this case, radius is 12. The theta we found from above down here. So what we have is 1.736, use a truncated value, plus 12 plus 12. So if you work all that out and give your final answer. Now we are on trig 17, found on page 63 of your textbook. Okay, so now what we're trying to do here is to find the length of OA. So OA can be found here. Okay, so first I let OA be equals to RCM. Okay, now they also give me this piece of information where they say that the length of the arc BC is 5 meters less and twice the length of arc AD. So I think what we want to do here is first we find the length of arc AD, we find the length of arc BC. So now AD is this arc over here. Since this is R, so AD is simply R times 2.5. Now for BC, alright, is simply r times theta. Be very careful now. What is the radius for the arc BC? The radius is actually here, which is r. plus 3 cm. Hence, for arc BC is r plus 3 times 2.5. Okay, now let's put all of this into an equation. The length of arc BC, which is this, the length of arc BC is 5 meters less than twice the length of arc AD. So I take twice the length of arc AD, alright, then I minus away 5 because it's 5 meters less. Then if I solve my equation, I can find that the radius r is, or the length of OA in this case, is equals to 5 cm. Okay, let's just bear in mind that r equals 5 cm. Then I shall shrink this so that I have more space to write. Okay, let me just put it aside there. Now, I will now move on to part B. What we want to find is a parameter of A, B, C, D. So it's A, B, C, D. Alright, so be careful. So it's made up of 4 parts. The first part is made up of the 2 arcs. Then you don't forget to add the 3 cm and the 3 cm there. So let me just write it down now. The parameter is equals to arc BC plus arc AD plus 3 plus 3. Okay, for arc BC, what we have is 5 plus 3. So it's 2.5. Okay, alright, times 8. Okay, wait, sorry, the length of arc BC is 2.5 times 5, correct? Okay, now the length of the arc AD is 2.5. Okay, I think I made a mistake there. Just give me a moment, sorry. The length of arc BC is r times theta. In this case is 5 plus 3 should be 8. Okay, so what we should have is 8 times 2.5 plus the length of the arc AD. AD should be 2.5. Okay, r times theta. The radius here in this case is 3, is 5. And we don't forget to add 3 and add 3 down here. So what we get is 20 plus 12.5 plus 3 plus 3. So the parameter of ABCD is 38.5 meters. Okay, let me just shrink this so I have a bit more space to write. Finally, we look at part C, the area of ABCD. We have done something similar, okay, when we did the areas of sectors and segments in 2.2, I believe. So now, what we do is we take the area of the largest sector, OBC, okay, so we take the area of the largest sector, OBC. We minus away the area of the smaller sector, which is OAD. Then what we're left with is this portion here that we would want. So I will say that the area equals to area of sector OBC minus area of sector OAD. So area of sector OBC is half times r square times theta, which is 2.5, minus away half times r square, which is 5 square, times theta, which is 2.5 as well. So if I work it out, it's an exact answer, 48.75 cm square. Okay, now I'm going to move on to the exercise 2.4. I give you a few more examples before I set you your homework. So this is question 4, all right, found on page 64. So now, first, they tell me that angle AOB is 2/3 pi radians and the length of the arc APB, alright, is 8 pi cm. So down here is 8 pi cm. Find the radius. I think this is quite a simple one. So what we do here is this. Arc length is r theta. Okay, so now since the radius will be r, so I say r times theta, which is 2 pi over 3, is equals to the length of arc, which is 8 pi. If you just solve it very quickly, the radius is 12 cm. Okay, next they want the area of sector OAPB. So the area of sector OAPB is equal to half r square, which is 12 square, times theta 2 pi over 3. if you use your calculator to work it out, is 151 cm square, correct to 3 significant figures. Now they want you to find the length of the arc AQB over here. Okay, so if I want to find the length of arc AQB, what I need is to find this angle here. So if you remember for radians, okay, pi radians is equals to 180 degrees. What is 360 degrees? It is 2 pi radians. So what we're doing here is this. We will need to take 2 pi radians, which is the whole round, minus away 2 pi over 3, so that I can get this angle over here. So what I will do is this. I will say that reflex angle AOB is equals to 2 pi radians minus 2 third pi. Okay, so what I get is 4 pi over 3. So let me just help you here. Let me just go and label it there. This angle over here is 4 pi or 4 third pi radians. Now that we have that angle already, we can do the rest of the question. So now if I want the length of arc, okay, so if I want the length of arc AQB, what we get is r times theta. So it's r times 4 pi over 3. You work it out, you get 50.3 cm. I'll complete the rest of the question up here. The area of sector OAQB is equals to half times r square. R square is still 12 square, and theta, be careful, the theta that we need is this theta over here, which is 4 pi over 3. So if you work it out, what you'll get is 302 cm square. Okay, this is the very last question before I will set you your work via ClassCake. This is question 10, okay, of this exercise 2.4. Okay, this diagram shows the water surface of a jacuzzi pool is a segment. If you remember what a segment is, okay, let me just draw for you. Okay, segment means that you have a chord like this. Okay, you cut this. This area that I'm coloring is the major segment. This area here is the minor segment. So now they say that the is a segment of a circle with center O, radius 3 cm. The chord AB is 5 meters long. Find AOB in radians. Okay, so what we have here is this. I just focus your attention on this triangle over here. This is 3, this is 3, this is 5. I'm trying to find this angle here. So we start counting. 1 side, 2 sides, 3 sides, and 1 angle. So 3 sides and a single angle. What we'll apply is the cosine rule. So let me begin. Okay, for part A. So I'll say by cosine rule, 5 square equals to 3 square plus 3 square minus 2 times 3 times 3 cosine of angle AOB. So if I start to shift things around, I will find that 5 square minus 3 square minus 3 square divided by negative 2 times 3 times 3 equals to cosine angle AOB. Then angle AOB is inverse cosine of this whole value here. Then what you will get is angle AOB is 1.970 radians. Be very careful, okay? It should, your calculator must be in radian mode. If not, when you do inverse cosine of the value, what you're going to get is the angle in degrees. So please be sure that your calculator is in the correct mode. Then next, they want the perimeter of the pool. So perimeter of pool is made up of 2 things. First, we need this major arc over here, and we also need this chord over here. The chord is given, so now our job is just to find the perimeter of the major arc. So what I'll do here is this. First, we will need to find this angle over here. So this angle over here, we just take 2 pi minus 1.970 radians. Why? You know that this small angle here is 1.970 radians. One whole round is 2 pi radians. Hence, this reflex angle here is 2 pi minus 1.970 radians. Hence, let me just write that down for part C. The reflex angle AOB is equals to 2 pi minus 1.970 radians. Okay, now, so what we need is the perimeter. Okay, so the perimeter is actually equals to r theta. So the radius is 3, the theta is 2 pi minus 1.970. So what I've just written down is for the arc AQB. Then don't forget we need to add the chord AB, which is 5. So if you use your calculator, what you should get is 17.9 meters. Next thing is part C, the area of the water surface. So we need to divide up, so to speak, right, this diagram. So the area is made up of two things. One is the major sector, okay, and the other one is the triangle AOB. So now the total area is equals to area of major sector plus the area of triangle AOB. So area of major sector, we use half r square. R square is 3 square. Be careful with the theta. Which theta should you use? Should you be using 1.97 or 2 pi minus 1.97? In this case, you should use, since we're finding the major sector, you should use the angle that corresponds to the major sector, which is 2 pi minus 1.970. And we add in the area of triangle AOB. So we can use our trusty formula, half AB sine theta. Be careful here. Which theta do I use? Now, in this triangle, the theta should be the smaller angle in this case, which is this angle here, which is 1.970. Once again, I need to urge you to be sure that your calculator is in the correct mode. If you key everything to the calculator, you'll find that you'll get the answer of 23.6 meter square. Okay, we have come to the end of chapter 2.4, Formulae in